All right, so today we're taking a deep dive into deep learning.
Sounds good.
But we're not just going to, like skim the surface.
Right.
We're going to go, way deeper into how it's actually being used, like where it's headed, all that.
I like it.
And, we've got some really cool research papers here.
Okay.
One of them uses deep learning to predict local rainfall with like crazy accuracy.
Wow.
And then
Interesting.
we'll see, how this technology is changing education,
Okay.
what the future holds for deep learning.
The whole thing.
Yeah, the whole field. So
All right, I'm ready.
this first paper from the Indian Meteorological Department
Okay.
really caught my eye.
Okay.
They're using deep learning to predict rainfall at a hyperlocal level,
Wow.
like down to specific streets.
That's pretty impressive.
I know.
Yeah.
So what's the big deal about these like granular predictions?
Well, think about traditional weather forecasts. They might tell you there's like a 60% chance of rain,
Right.
but that doesn't help you decide if you need an umbrella
Yeah.
walking to your car.
Exactly.
This research is really focused on downscaling,
Okay.
which is taking, broad weather data,
Right.
making it relevant to your exact location.
So how much rain
Exactly.
is going to be on my tomato plants?
You got it.
Or if that outdoor concert
Yeah.
is going to get rained out.
Exactly.
Wow.
So you can plan accordingly.
That's amazing. But how do they even get
right.
such detailed data to train these models?
Yeah.
I mean, do they have weather stations on every corner?
That's the challenge.
Right.
They used existing weather data
Okay.
and trained deep learning models
Okay.
to generate higher resolution predictions.
So they're like
It's kind of like,
teaching the model to fill in the gaps.
yeah, taking a blurry picture,
Okay.
using AI to make it crystal clear.
So what kind of deep learning magic are we talking about here?
Well, they tested a few different methods.
Okay.
But the one that really stood out was something called an SRGAN,
Okay.
which stands for Super Resolution Generative Adversarial Network.
Okay. That's a mouthful.
It is a mouthful.
So it's like a neural network duel.
Exactly. You have one network, the generator,
Okay.
that tries to create realistic rainfall maps.
Oh, okay.
Then you have the discriminator network,
Right.
which tries to tell the difference between the generated maps
Right.
and real ones.
Oh, so
They
slick.
go back and forth,
Okay.
pushing each other to improve
Oh, that's interesting.
until the generator is producing amazingly detailed, accurate predictions.
Wow.
Yeah.
So like a game of AI cat and mouse?
That's a very apt analogy.
Okay.
And what's particularly impressive is that the researchers had to create a custom network architecture
Really?
to train this SRGN on precipitation data.
Wow.
It wasn't something they could just, pull off the shelf.
Right.
They had to really dive into the nuts and bolts of deep learning.
Okay, so that's where the real expertise comes in.
Exactly.
So did this custom-built SRGN actually deliver?
The results are remarkable.
Okay.
This model outperformed other methods, and the predictions aligned incredibly well
Oh, wow.
with readings from actual weather stations across India.
Wow. Yeah.
Now, it's still early research,
Right.
but the potential applications are vast.
So we might one day have weather forecasts
Yeah.
that are precise down to our neighborhood block.
Precisely talk about personalized weather reports.
Oh, right. That's amazing.
And this example highlights how deep learning is moving beyond theoretical research
Yeah.
into practical applications that can impact our daily lives.
For sure. For sure. Now, if we shift our focus to education,
Okay.
we'll see another fascinating area where deep learning is making waves.
Let's hear it.
I have this paper here that talks about deep learning's potential to personalize education
Okay.
and even predict student success,
Interesting.
which I'm all for, making learning more effective.
Right.
But I have to admit, the idea of algorithms evaluating students makes me a little uneasy.
I understand. It's
Yeah.
understandable to have some reservations.
Right.
This paper explores both the promises and the potential pitfalls
Okay.
of deep learning in education.
Okay.
And one of the most exciting possibilities is personalized learning.
Okay.
Imagine a system that can adapt to each student's individual needs,
Yeah.
providing tailored lessons and support.
That sounds incredible.
Right.
It could be a game changer for students who struggle in traditional classrooms.
Absolutely.
But how does deep learning actually achieve this?
Yeah, so the paper dives into several techniques.
Okay.
For instance, researchers are using graph neural networks, or GNNs,
Okay.
to analyze student interactions and predict how well they'll collaborate on group projects.
Interesting.
Another approach uses deep learning to analyze student code,
Okay.
identifying common misconceptions
Okay.
and providing targeted feedback.
So instead of a one-size-fits-all approach, deep learning could help tailor education to teach students strengths and weaknesses.
Precisely.
There's powerful stuff.
It is, but as with any powerful technology,
Right.
there are potential downsides.
Yeah, I was just thinking about that. What are some of the ethical considerations?
Yeah. One of the biggest challenges is the black box problem.
Okay.
Deep learning models can be incredibly complex,
Right.
making it difficult to understand why they make certain predictions.
Okay.
This lack of transparency can raise concerns about bias fairness,
Right.
the potential for these systems to perpetuate existing inequalities in education.
So we might know that the algorithm is predicting that a student will struggle,
Right.
but we don't necessarily understand why.
Exactly. And without that understanding,
Yeah.
it's difficult to address the root causes of the problem or
Right.
ensure that the system is being used fairly.
That's a crucial point.
Absolutely.
We need to be very careful
Very careful.
about handing over such important decisions to algorithms
Yeah.
without fully understanding how they work.
You got it. And that's why researchers are working on something called explainable AI or XAI.
Okay.
It's a field dedicated to making these black boxes more transparent.
So like giving the algorithm a voice to explain its reasoning?
In a sense, yes. Imagine being able to see not just the prediction,
Right.
but the specific factors the model considered and the logic it followed.
That would be game-changing, especially in education.
Right. It could help us identify potential biases,
Yeah.
ensure fairness.
And even gain valuable insights into how students learn.
Exactly.
Oh.
It's a critical area of research, and it highlights the importance of not just developing powerful AI systems, but also ensuring that they are used responsibly and ethically.
Yeah,
So,
absolutely. So it seems like deep learning has got this huge potential to really like change education.
yeah,
But obviously we got to be really careful with
Right.
all the ethics involved.
it's a delicate balance for sure
Yeah.
as we kind of go deeper into the world of deep learning.
Right.
You know, all these considerations get even more complex.
Yeah.
Take multimodal learning, for instance.
Okay.
It's like one of the most exciting frontiers in this field.
So multimodal learning,
Yeah.
that's where AI systems learn from multiple types of data at once.
You got it.
Like combining text, images, and sounds.
Exactly. Like imagine a deep learning model that can like see a photo of a bird,
Right.
but also read its scientific description and hear its song.
Oh, wow.
So by combining these different like modalities, the model can get a much richer understanding
Okay.
of the world.
That's amazing.
Yeah.
But wouldn't processing all that data be incredibly challenging?
It definitely is. It's a complex task.
Right.
One of the key challenges is, you know, you need really robust data processing techniques.
Okay.
Ensuring the quality, the safety, and the balance of the data
Right.
becomes even more crucial when you're dealing with multiple modalities.
So it's not just about, collecting a ton of data.
It's not about quantity, it's about quality.
Right. It's about making sure the data is clean, diverse,
Representative
of the real world.
Yeah.
Okay, so think about, like, if you're training a model
Yeah.
to identify different bird species,
Okay.
you don't want it to be biased towards birds that are
Right.
commonly photographed or whose songs are easily recorded.
Exactly. You need a wide variety of
Yeah.
species from different habitats and regions.
That makes sense.
Yeah.
So creating these data sets,
It's a huge undertaking.
I bet.
Yeah.
How do researchers even begin to tackle that?
It's a multifaceted process.
Okay.
Researchers are using techniques like data augmentation
Okay.
to create variations of existing data.
Uh-huh.
And they're also leveraging tools like ChatGPT
Oh, interesting.
to generate synthetic data.
Wow.
So, and they're also focusing on collaboration and data sharing
Okay.
to kind of pool their resources and expertise.
So it sounds like the success of this whole multimodal learning thing hinges on this.
It really does.
Collaborative spirit.
Yeah.
Okay,
Yeah.
and as these models become more, sophisticated,
Yeah.
the need for like diverse perspectives and ethical considerations
It's
is
only going to grow.
going to grow.
Yeah. We need to be mindful of potential biases in the data,
Right.
ensure privacy and security, and be transparent about how these systems are being used.
That's a good point.
Yeah.
It's clear that building these advanced deep learning systems requires a really solid foundation,
It does.
which makes me think back to our discussion about object-oriented programming.
OOP.
Yeah,
It all connects.
it does.
Yeah, OOP provides this structured approach to building these complex software systems.
Right.
And that's essential for deep learning.
Yeah.
It allows you to break down these intricate models
Okay.
into manageable components,
Uh-huh.
makes the development process more organized, efficient, and scalable.
I remember you saying that OOP is like the grammar
It is.
of programming languages.
Yeah.
Now I'm really starting to understand why that grammar is so important.
Think of it this way. If you want to write a beautiful and compelling story, you need to understand the rules of grammar
Right.
and syntax.
Yeah.
Similarly, if you want to create these powerful and robust deep learning systems, you need to master the principles of OOP.
Okay, so OOP is the foundation. And from there, we can build up to these incredible applications.
Exactly.
Like multimodal learning.
Yeah.
And hyperlocal weather prediction. But where do we go from here?
That's the million-dollar question.
Yeah, what's the path forward?
One exciting avenue is the development of even more sophisticated neural network architectures.
Okay.
We're seeing a lot of innovation in areas like transformer networks and graph neural networks, which are capable of handling increasingly complex data relationships.
It seems like there's this constant push to create models that are more powerful, more efficient.
Absolutely.
More capable of, like, mimicking human intelligence.
It's the ultimate goal.
Where does that drive come from?
I think it stems from a desire to solve some of the world's most pressing challenges.
Okay.
Deep learning has the potential to revolutionize healthcare, accelerate scientific discovery, create personalized learning experiences, and even address climate change.
Wow.
The possibilities are truly limitless.
It's both inspiring and a little daunting.
It is.
To think about the scale of what's possible.
Yeah, but for someone who's just starting out in deep learning,
Right.
what's a good way to approach this vast field?
Yeah, where do you even begin?
That's a great question. Deep learning can seem overwhelming at first.
Yeah.
But the key is to break it down into manageable steps.
Okay.
Focus on building a solid foundation.
What are those essential building blocks?
First, you need a strong understanding of the fundamental concepts of machine learning,
Okay.
such as supervised and unsupervised learning,
Right.
different types of models, valuation metrics.
Gotcha.
And from there, you can delve into the specifics of deep learning, starting with basic neural network architectures,
Okay.
like feed-forward networks and convolutional neural networks.
So it's about building up from the basics.
It is, layer by layer, just like a neural network itself.
I like that.
And don't be afraid to get your hands dirty with code.
Okay.
There are fantastic resources available online,
Right.
including open source libraries like TensorFlow and PyTorch.
Yeah.
They provide a great starting point for experimentation and learning.
So deep learning is as much about practical experience
Absolutely.
as it is about theoretical knowledge.
The best way to learn is by doing.
Okay.
Start with simple projects, gradually increase the complexity, and don't be afraid to make mistakes. That's how you truly gain a deep understanding.
Okay. That's encouraging advice.
Good.
But deep learning isn't just about writing code, is it?
No, it's not.
There's a whole creative aspect to it as well.
You're absolutely right.
Yeah.
Designing and implementing deep learning solutions requires creativity, problem-solving skills, a willingness to think outside the box.
So it's not just for, like, computer science whizzes.
Not at all.
It's for anyone who's curious, passionate, and wants to make a difference.
That's a great way to put it. Deep learning is a field that welcomes individuals from diverse backgrounds and disciplines.
That's great to hear.
Yeah.
But for those of us who aren't quite ready to dive into all the technical details,
Right.
how can we still engage with the field of deep learning in a meaningful way?
There are many ways to stay informed and engaged with the advancements in deep learning, even without a technical background.
Right.
You can follow thought leaders in the field, read articles and blog posts, attend conferences and webinars,
Right.
and engage in discussions online.
Gotcha.
The key is to stay curious and informed about the potential impacts of this technology on society.
It sounds like deep learning is not just a field of study, but like a cultural phenomenon.
It is.
It's shaping our world.
It's shaping our world in profound ways. And as with any powerful force, it's crucial that we approach it with both enthusiasm and a healthy dose of critical thinking.
I agree.
We need to be aware of the potential benefits and risks.
Yeah.
Ask tough questions.
For sure.
Work together to ensure that deep learning is used ethically and responsibly for the betterment of humanity.
That's a powerful message to end on. But before we wrap up this deep dive, there's one more aspect of deep learning I want to touch on.
All right, I'm listening.
It goes back to our discussion about multimodal learning.
Okay.
And the challenges of processing vast amounts of data.
Okay.
We've talked about all the technical aspects of data processing.
Yeah.
But I'm also curious about the human element.
Okay.
How do we ensure that the data used to train these powerful AI systems is fair, unbiased, and representative
Right.
of the diversity of human experiences.
That's an excellent point. The data we feed into these algorithms will ultimately shape their outputs
Right.
and influence their impact on the world. So it's crucial that we address issues of bias representation and inclusivity right from the start.
It sounds like we need a more holistic approach to deep learning,
I agree.
one that considers not just the technical aspects,
Yeah.
but also the ethical,
Yeah.
social, and cultural implications.
You got it. The future of deep learning depends on our ability to balance technological innovation with human values
Right.
to create systems that are not only intelligent, but also just equitable and beneficial to all.
That's a profound thought, and it's something I'll definitely be pondering as we continue
Yeah.
this exploration of deep learning.
I'm glad to hear that it's a conversation that deserves our full attention and engagement.
Wow. It feels like we've just scratched the surface
Yeah.
of deep learning, and yet we've already covered so much.
Yeah.
From hyperlocal weather predictions
Right.
to personalized education, the possibilities seem endless.
It's true.
Speaking of challenges, we talked about the black box problem
Yeah.
and the need for explainable AI.
Mm-hmm.
Where do you see that research heading in the next few years?
Well, explainable AI is becoming increasingly important.
Right.
Especially as deep learning models are being used in high stakes applications.
Like healthcare?
Yeah, healthcare finance, things like that.
Right.
So researchers are developing these really innovative techniques
Okay.
to make these complex models more transparent and interpretable.
So instead of just getting a prediction,
Exactly.
we might also get an
You
explanation
got it.
of how the model arrived at that prediction.
Imagine a doctor using a deep learning model to diagnose a patient
Okay.
instead of just getting a diagnosis.
Right.
They could also see the factors the model considered, the medical literature it referenced,
Rob,
the reasoning behind its decision.
that's incredible.
It would give doctors more confidence in the model's predictions
Right.
and allow them to make more informed decisions.
That level of transparency would be transformative.
It would.
It would not only make these systems more trustworthy,
Uh-huh.
but also help us understand their limitations and potential biases.
Exactly. And as we develop more sophisticated deep learning systems, it's crucial that we don't lose sight of the human element.
Right.
These are powerful tools,
Yeah.
but they should ultimately serve to enhance human capabilities, not replace them.
That brings us back to, a theme we've touched on throughout this whole deep dive.
Yes.
The need for a balanced and thoughtful approach.
Absolutely.
Deep learning.
We need to foster this culture of responsible innovation
Okay.
where we carefully consider the ethical, social, and economic implications of these technologies before, deploying them on a large scale.
It's a complex challenge,
It is.
but it's one we can't ignore.
Oh, can't.
Deep learning has the potential to reshape our world
Yeah.
in profound ways.
And it's up to us to ensure that those changes are for the better.
Well, as we wrap up this deep dive,
Okay.
I'm left with this sense of awe, the incredible power of deep learning,
Yeah.
but also, a healthy dose of caution.
A healthy dose.
It's a technology that demands our respect, our attention, and our careful stewardship.
I couldn't agree more.
I want to thank you for joining us today
Thank you for having me.
on this fascinating journey into the world of deep learning.
It's been a pleasure.
We've only scratched the surface, but I hope this conversation has sparked your curiosity,
Yeah.
inspired you to learn more.
That's what we were hoping for.
This is a field that's constantly evolving,
Always changing.
so stay curious, stay engaged.
Absolutely. And remember,
Yeah.
deep learning is not just a technical field,
Mm,
but a human endeavor.
right.
It's up to all of us to shape its future and ensure that it serves humanity in a positive and meaningful way.
Couldn't have said it better myself.